All right, thank you very much, Samuel. So today we have a guest speaker, and it is our great pleasure to have today Dr. Gordon Reach from the United Kingdom. He is a specialist in the field of radiation oncology mathematics. He studied both university mathematics and science before he entered into medical school to become a doctor. He just followed a lot of projects and did a lot of things. Like he worked also for 10 years in Africa before returning to the United Kingdom. And he has been practicing radiation oncology as a consultant for more than 40 years now. And now for the last 7 years, he has been really specializing on the field of mathematics and radiation oncology. He will tell you himself, like how much things he's been working on and how much stuff he's collected on it. He's currently writing a book and has already, if I remember correctly, over 800 pages of documents on all kinds of mathematics related to radiation oncology. And I'm really looking forward to hear your talk, Gordon. Thank you very much for giving this webinar today for the ISROI, and we're very grateful and happy to have you today. I think you need to unmute. You're still, your microphone is turned off.
Now, can you hear me now,
Hi,
Fabio?
everybody.
Yes, well, guten Tag.
Yeah,
guten
it's working
Tag.
well.
Wie geht's? Gut?
Guten Tag.
So,
Hello.
that's as much German as I will say this afternoon. But it's wonderful to be linking up with you all. I've got very, very strong associations with Germany, Austria, and Switzerland, and indeed Paris in Italy. So now, what I'm going to try and do this afternoon is to really describe to you in a way, more than detailed mathematics, the philosophy, the actual practical academic approach to the problem. The problem is vast. Truly, it is vast. Over the last few years, as Fabio has so kindly and generously mentioned, I have spent time collating, collecting mathematical symbols, of which there are over 2,400, which apply to radiobiology, radiological physics, biostatistics for oncology, and the modern radiation technology of oncology. I am confining and have confined my concern and interest in simply trying to provide the platform from which, particularly those in training. I'm sorry, most of you, I gather, are fully fledged oncologists, so I apologize to you for not necessarily providing anything new in terms of detail. But what I would very strongly encourage is that at as wide a scale as we can, both nationally, internationally, and for those of us, I mean, I'm involved with aortic, which you might think is to do with the aorta. It's not at all. It's the African Organization for Research Treatment in Cancer, of which there are over 2,000 members. And I had the privilege of being a potential vice president for that association. And again, it was very much on the basis of the need for fundamentally sound educational background for our professionals in the sphere of radiation oncology, but where aortic was concerned, also medical oncology and so forth. So what I would like to do now, technology providing, is to start a slideshow. And here we are. So slide number 2, the basics. Now, when you've got the postgraduate there in training, he may be wanting to grapple with quadratic equations and complex integrals and derivatives. But it's so important that the first attitude of mind and heart in this subject is to understand concepts, to understand units, rather to try and memorize. There is a huge amount to memorize. For those of us who trained many, many years ago, the mathematics was relatively untouched, untalked of, certainly not considered to be such a vital component to promoting the available clinical and radiobiologically orientated technology. So the first principle is avoid memorization. It is the understanding which is so important. But before you can understand any mathematical equation relating to these four subjects that I've referred to, you do have to, the students, postgraduate students, will have to understand the actual concept first. Absolutely fundamental. Now, every single term, abbreviation, symbol, or notation needs to be gradually built into one's own personal library. The postgraduate students, those in training, must be encouraged to gradually build their own. We use the English expression compilation, compile, bring together all the, and as I think I've mentioned already, I have collected over 2,400. And what is so important is you pay attention to the description of um, each of these terms, abbreviations, vital though they are, need to be understood what they stand for. I'm saying things were such as so obvious, but when you read the textbook of radiobiology, for example, sometimes I am so disappointed and disheartened that there is not adequate explanation of what the structure of that particular equation or formula, what it is when you break it down component by component. You probably know from your own work how important it is to make sure that the symbol, for instance, that one is employing is related to the context in which you're wishing to employ it, because different symbols have different meanings in different contexts and allied subjects. So on this first slide, compilation of terms, abbreviations. Now, one golden rule is that you must not, I think I've got this down. Oh, yes, it's the very next line. Avoid abbreviation of abbreviations. Make sure that the abbreviation with either, if it has a superscript or a subscript, those are vitally important. It's no news to you at all of the importance of the Greek alphabet, and familiarity with every single symptom symbol of the Greek alphabet is, when you look back at the dictionary that you have compiled for yourself, you will realize that nearly every letter in the Greek alphabet is employed in some form or other in these four subjects relating to radiation oncology. Now, when you come to look at textbooks, you very often find that there's reference to terminology which is no longer applicable, which is no longer employed, which is no longer considered to be relevant to contemporary practice. So it's important, if you're looking at things spread over 2 to 3 decades, that you make sure that the information you're providing for your postgraduate students relates to current terminology as opposed to being things which are historical. Ellis's formula, most of you are very familiar with that. That is historical now. Next point on this first slide, memorization of important values. I mean, you must know, you must know the value of E to 6 decimal places. And the 712,282 being 712,282. And pi, you must know that 3.141. I think it's then a 6. Am I right, Fabio? I hope I am. Radians, a vitally important unit concept, approximately 57 degrees. Now, as I've already indicated, it's for the postgraduate student, it's so helpful if from the beginning they approach an equation or a formula or some form of mathematical expression or structure, if they analyze component by component. What I found really almost disheartening is when I came to look at the textbooks available in radiobiology, and I'm not going to mention the particular one, which is over, I think it's 352 pages that I have studied. I've been somewhat disheartened by the fact, as mentioned already, that component, not every component is identified, sorry, the better word would be defined. It's so important that every single symbol, even simple things like brackets, most important that you understand the concept in which they are used. So you have to go back to being medical students and undertaking dissection of every mathematical expression. And do not believe, and I certainly have found this in the last 2 or 3 years when I've been trying to put myself in the shoes of postgraduate oncology trainees. Do not deceive yourselves that you will understand at the first reading a mathematical formula relating, for instance, to some aspect of radiobiology. I do not believe that comes naturally, even for those gifted in mathematics. It takes time, and it's the marrying together of the mathematical background, concept, expression with the biology, with the radiation biology, which is really difficult. And I don't believe there is currently a radiobiology textbook which does that. I think the English expression would be seamlessly, meaning, in a sense, without difficulty. So people, postgrads, need time to assimilate. Now, we could spend a whole 40 minutes on definitions and terms, but I've just put down here in this particular slide a few definitions, which some of which are very often. I must say, I struggled for some time to fully comprehend the concept of a domain, for example. And the way that textbooks normally or dictionaries identify this particular term and its explanation is a function going from a starting point of S to T, in which each element within that function is the domain, and there is the unique element of T, which is the codomain. Argument of a function may sound a strange expression, but that is, I think everybody will appreciate, is that which appears within brackets. And the value of the argument is that which determines the value, the outcome, the value of the dependent variable. An algorithm, most important concept to appreciate, is a mechanical procedure for solving a problem in a finite number of steps. Next few things are fairly obvious. Will be obvious to yourselves, but to the postgraduate in training: discrete variables, continuous variables, those which are dependent on other factors, and those which are clearly independent. Now, in statistics, they often use the term a predictor variable, another term for which is explanatory variable. And it's considered to be any factor which might influence the value of the dependent variable. So if we go on to the next slide, well, this is pretty straightforward, so I won't dwell on it too much. But for the when people come into radiation oncology, they haven't necessarily got mathematics even at senior level at school. So I'm very fortunate in that I studied pure and applied mathematics, physics and chemistry before attempting to go into university, and then had to do biology and mathematics at university before I was allowed into medical school. But even such concepts as proportions, percentages, histograms. I think what's really helpful, particularly in radiobiology, is the visualization. Excuse me, the visualization of mathematical material, and so graphs. I would put huge emphasis on early on in the postgraduate curricula, study graphs, look at histograms. Don't worry too much about rather more complicated things such as polynomials and power series. But maybe I'm reflecting on my own tendency to have a photographic memory rather than an analytical one. So graphs are very important, and we'll come to a little bit more on that later. Fabio and Samuel, I'm keeping an eye on the time. I've already mentioned, and woe betide us if we don't know the value of E and I, and it's certain things help hugely if they are committed to memory. I think I've seen a book. Fabio, you may have seen this, a book in which E is expanded to something like 400,000 decimal places, because it goes on forever. It's a most fundamentally important number and concept in our work, as I'm sure nearly all of you will appreciate. Now, coordinate systems. I'm sorry I haven't provided any graphical information myself, but coordinate systems, everybody is familiar, but possibly not identifying in word an expression the Cartesian coordinate system, in which the position of a data point is determined by its relationship to the y ordinate axis, or the x abscissa axis. I won't dwell too much on that. And then, of course, there is the polar coordinate system, in which there is the fundamentals of r, the length, and theta, the angle portrayed by the in graphical form. We've already mentioned about the value of a radian, and that's useful to recall or remember. Now, mathematical signs and concepts. Well, we're still on the philosophy. Still adopting an analytical approach when reading a new section relating to radiation oncology. To understand the structure of the formula, not necessarily to be able to fully comprehend what that formula means. That, I believe myself, only comes with considerable experience. The importance of brackets. I've mentioned already different types of brackets and the actual numbers employed. Here, with whether a letter is expressed as in upper or lower case. Now, I've tried, I hope you can see this next line, distinguishing between the different forms of letters, the conventional R for Arontian, and then the I'm not sure whether you would call this a Greek letter or not, but it's another form of R, which relates and identifies the range of applicability. Next slide. Focusing on the qualification within the brackets of functions and equations and formulae. Absolutely fundamentally important to understand what that function, equation, or formula is trying to convey. It's the things that come after the letter F in brackets. What is it really? And those particular sub-entities are separated by commas. Now, units, oh my goodness me, you wait till you start compiling in your own dictionary of material, the different units that are employed, both historically and currently, and relating to every aspect of our work. And obviously, many such units relate to the SI system. Now, when writing things out, some people think this is unimportant, but not so those who are particularizing in providing contemporarily accurate, educationally acceptable formulation. So, for instance, I've just put down 21 kg. It's not 21 kg merged. There has to be a gap. 15 MeV. It's not when it is merged. So attention to those details makes such a difference. Symbols for physical quantities in italics, symbols for units in Roman style. Absolutely universally recognized. Now, dimensions, scales, looking at graphs. Are the systems arithmetic? Are they geometric? Are they logarithmic? Is one logarithmic and the other arithmetic? such as in semi-log scales. These help to crystallize the actual meaning for radiobiology in particular. It's terribly important. If you look at, for example, just to give you one brief example, one of the great classical ones, which I think is salutary, is so instructional, is to look at cellular division, um, um, up to a point where tumor cells have assumed a cellular population of 10 to the ninth cells, by which time they have formed a tumorous mass of about 1 centimeter diameter. Well, if you plot that on an arithmetic scale, it's a totally erroneous concept, the projection. If you do it on a logarithmic scale, you then realize that there are multiple cellular divisions taking place until such point as it assumes clinical relevance. Whereas if you plot it on an arithmetic scale, you get a completely, as I say, erroneous impression and conclusion. Yes, next point, I think it's pretty obvious that sometimes symbols have different meanings in pure mass, radiological physics, biostatistics, or MTRO. So again, the relevance, the contextual relevance is very important. Now, I'm looking at the clock, it's half an hour. I'll go on for another 10 minutes, if I may, Fabio. And Samuel, it's when it comes to describing mathematical precision, it really is important to state whether this is an approximation or it's in fact an expression of precision, of exactness. And what is even more important at times, certainly relevant when considering things in the radiobiology field, is to know the range of applicability. Some mathematical expressions will very aptly describe a radiobiological process, but only for a certain range, outside of which the whole concept can be undermined, and the mathematics of such part of the presentation inappropriate and misleading, and of course can have clinical implication. Now, I've already on this next slide referred to. I'd like to get just after at least 2 or 3 minutes on radiobiology itself. We've already mentioned about domains and equations, graphs, formulae. Clearly, to understand a lot of the radiobiological events, one has to understand the basics of both differential and integral calculus. Arithmetic series, geometric series, pretty straightforward. Angles, very important to understand the difference between acute, obtuse, right angles, and for those who wants to go into greater detail, compound angles. Now we come to, I think in a later slide, I'm going to emphasize this even more. You'll all be aware of the graphical representation of exponential growth and exponential decay. And the next line, I think, is one of the most important concepts for a radiation oncology trainee or a radiation physics trainee or an RTT to understand, is the relationship between exponential and natural logarithms, the inverse relationship between the two. Absolutely fundamental for understanding so many mathematical expressions. Um, Factorials, I think you will all know what they are. Roots are can be very important. Vectors, of course, are not just considerations of magnitude of events, but also the precise direction. Where are we up to? Um, Functions, I think we've covered quite a number of those things. To understand sine, cosine, tangent, for those who didn't do mathematics at A level at school, well, they've got to learn the opposite and hypotenuse, adjacent and hypotenuse, opposite and adjacent, absolutely fundamental geometric relationships. Um, um, I won't spend too much more time on that if I may. I think I've got another 5 minutes. So what I've done here, I hope you can see this slide. It's not. It's actually my own terrible handwriting, folks. I'm sorry, but here I've tried to emphasize the importance of studying, understanding, thinking, utilizing and drawing on examples of the importance of Euler's constant E, the exponential. If there's any letter or any symbol or any concept which is important for us in our work, it is the letter E and exponentials. And I mean, the introduction to our work, it right away people have to understand what is meant by exponential growth of the tumor or exponential decay in response to radiation treatment or chemotherapy or the combination. So the letter E and its special function, it's a curious thing. Try to differentiate E and you still get E. Try to integrate E and you still get E. So it's got a very, very central position in not only in oncology, but also in mathematics in general. And I think I then have gone on to put down some logarithmic relations, and there is an omission. Gordon Alistair, his other name, that is an incorrect one there. But you notice here the minus sign, very important to pick up on the full expression. And so there are showing clearly the importance of E. Now, where are we up to in the so I've tried to convey, yes, you first of all got to identify mathematical expressions, pretty obvious. Good idea to draw up your own compendium, your own dictionary of mathematical rules. And once again, emphasizing the basic features and structure of formulae. Now, so I won't spend too much on this because we've indirectly referred to obviously series convergent coming together, divergent going to separating going to infinity, arithmetic, geometric, those influenced by a power function, logarithmic. Now, radiobiology. Well, we haven't got too much time to discuss this, but it's important right from the start that people understand what is referred to as a sigmoid curve. Sigmoid curve in one direction, going in the opposite direction, the reverse sigmoid curve. The significance of the shoulder of a sigmoid curve. Recognizing what was overlooked for many years was the extreme sensitivity of response of a tissue or a tumor to radiation in the low dosage range. The range, a phenomenon which is now referred to as a hyperradiosensitivity event and phase. So the shoulder of a sigmoid curve until it meets the extrapolated linear section of the curve, thereby enabling people to want to calculate what's called the quasi-threshold dose, otherwise known as the DQ level. We haven't got time to go into the description of the various interactions between radiation and biological cells in terms of the number of targets and how many hits are required to eliminate future cellular reproduction. But the DO is, sorry, that should be a subscript there. The DO, dose giving 1 hit per target, reducing survival from 1 to 0.37, which is the exponential factor to the power of -1. And then I've gone on to mention the straight portion of a sigmoid curve. Now, I think everybody will be aware that to describe to describe the graphical form of a surviving fraction after radiotherapy, it's essential to use a logarithmic scale. If you're just in terms of the fraction of cells which undergo apoptosis, cellular death, in other words, then you can employ the arithmetic scale. For relative tumor volume, an arithmetic scale is really acceptable. Well, now, where are we up to? Oh, this, yes. Something I make a point of to myself is when I'm looking at graphs, I do not believe it immediately conveys the message of the graph where you've got labeling of the vertical axis vertically. And I believe that there should be horizontal labeling of graphs. Makes it so much easier. Instead of having to turn the textbook through a right angle to see what that ordinate, the y-axis parameter is, you can see it immediately if they horizontally label. But textbooks do not do this. Couple of brief abbreviations here. The effective dose for killing a 50% is known as the ED50. For killing 90% is ED90%. ED90. And it's a mathematical reality that a semi-log plot will result in a straight line for random cell killing as survival is an exponential function of dose. Now, that perhaps needs a little digestion. Now, so I come, therefore, I think I've had 40 minutes, Fabio and Samuel. This is what I propose in the future, is to try and help wherever possible on a one-to-one basis, webinar basis, larger groups, a 3-day seminar. I'm quite happy to travel to different parts of the globe, but particularly in Europe. And I'd like to summarize what I've tried to convey to you is in your own terms, in your own way of looking at things, to construct item by item a mathematical toolkit, a way in which you can put into radiobiological or physical reality a concept mathematically. and it's something which I think does vary from one person to another. But I would strongly encourage everyone who is studying this wonderful, wonderful science and subject and clinical discipline of radiation oncology to stand back a little bit from textbooks initially and determine the way in which you're going to bring together all the vast amount of information. I would like you to really believe I am not exaggerating, and not nor am I claiming any merit. But I have collected and collated over 800 pages of equations and concepts. It, every single one of which has some sort of mathematical inference, usage, and meaning. And it's this sort of analytical approach that I would strongly encourage. And I just hope and pray that there will be a team of radiobiologists out there who will write a textbook in which it is going from one statement to the corresponding mathematical expression that there is shown to be a logical link, because so often they miss that out. And I have spent, I won't say hours, but I've certainly spent 10, 15, 20 minutes to try and understand one or two of these equations, analyzing them, and trying to work out what is the steps by which this equation or mathematical representation has been, how have they been reached? So it is understanding rather than memorization. Now, I think I've spoken for long enough. I'm sorry, I apologize profusely to those already fully trained in radiation oncology. But we all have the responsibility of teaching the next generation. So my talk, for what it's worth, has been really to encourage the teachers or those in learning to adopt an analytical approach, to compile, and not to necessarily want to come away thinking, yeah, I understand that formula, I understand that mathematical expression. In following the first reading, because it takes time for certain concepts to be second nature to ourselves. Thank you very much for listening. I hope to hear from some of you. I've given my details, contact details here. So do feel free to be in touch either by email or mobile phone. And just to let you know, I have the privilege of being a Life Fellow here at the Royal Society of Medicine, from which this broadcast is taking place. So thank you very much for your attendance, and I hope I can help you answer any questions that you may have. Thank you very much, Fabio and Samuel. Okay, over to you.